So now we're going to talk about equivalent fractions. Two or more fractions that represent the same portion of a whole. For example, if I were to take a pizza that we have here, and I slice it into 4 pieces, and I take one of those pieces, then we both agree that I've taken 1/4 of that pizza. On the other hand, if I have the same pizza, and instead of having sliced it into 4 pieces, I now slice it into 8 pieces. Now, granted, these drawings may not be representative, but we can imagine that they're perfectly sliced into 8 equal pieces on this side, 4 equal pieces on this side. Now, if you notice, if I slice 2 of these 8 slices, I'm really choosing a part of the whole, a part of the pizza that measures the same as I chose 1 slice out of 4. And so that's what we mean when we say that they're equivalent. But also, it helps us to have another way of characterizing equivalent fractions. That is, that we can get one from the other by multiplying by a fraction that equals 1. We remember from before the important fact that a fraction is equal to 1 if it has the same numerator and denominator. In this case, if you notice these two fractions, what happens if I multiply the fraction 1/4 by the fraction 2/2? What happens if I multiply these fractions? Well, we see that the product, as we saw before, will be gotten by multiplying the numerators to get the new numerator and multiplying the denominators to get the new denominator. The denominator is the product. And if we carry out this, what is 1 times 2? It's 2. What is 4 times 2? It is 8. That is to say, we have gotten this fraction by multiplying this fraction by a fraction that equals 1, 2/2. And so we see here that these two conditions represent the same idea. This part captures what we intuitively believe two equivalent fractions to be. That they're two fractions that represent the same part of the whole. And this characterization allows us to go from one fraction to another fraction that's equivalent. Although we have not pictured it here, I could easily take 1/4 and multiply it by the fraction 4/4, which equals 1, and arrive 1 times 4, 4 times 4, and arrive at the fraction 4/16. And because I'm taking our original fraction, multiplying it by a fraction that equals 1, I get a new fraction, 4/16, that is equivalent to the original fraction, and so on and so forth. In other words, I can form many other fractions, infinitely many other fractions that are equivalent to any given fraction. Now we're going to see that this has a very useful application right now when we're adding and subtracting fractions. But now I hope to leave you with this idea of having these delicious pizzas. Yum! Okay.